Alright, suppose you're asked to differentiate from first principles y is equal to x to the power n. How would you go about that simple question? So you know that from first principle, you basically differentiate by using the limit as h approaches 0. Okay, just take note in some cases where there's h, you can use delta. So h approaches 0, the function of x plus h minus the function itself divided by h. Alright, so if you're looking for a video where I've explained this formula in detail and how it comes about, check the description for that video. But well, let's just solve this question using the same method. How do you go about it? Okay, so very simple. We understand what functions are before we do calculus, right? So when I say f of x is equal to x to the power n, if I'm asked to determine f of x plus h, what that implies is where there's x, we put x plus h as well, and then it will still be raised to the power n as well. So let's substitute these two in our equation there. So what are you going to see? What you're going to notice is, okay, let's just substitute. F of x plus h is this part, so therefore we have x plus h raised to the power n minus f of x, which is just x to the power n. Okay, now can we simplify that from that point easily? Okay, so how can we deal with this? This is a case where we don't know the number. Any is a representation of any variable or any integer that you can have, okay, or possibly any real number. So how do you go about it? So let's do this. This is something we can expand by binomial, right? Okay, so from binomial theorem, I don't want to explain binomial theorem. We know that in an instance where we've got a plus b or a plus x, this is basically going to be equal to a to the power n plus n a, that is n minus 1, and then multiplied by b plus dot dot. The last term is going to be b to the power n. So you can actually try this using the binomial theorem, or you can use the Pascal's triangle, but the binomial theorem will actually be easier. So you understand where this will come from when you've got n choose 0, and then you have a raised to the maximum power, and then you've got your b raised to 0 plus n choose 1, a n minus 1, b will now be to the power 1. This is where everything is coming from, okay? And then dot dot, the last term should be n choose n, and then it will be a will be the power 0, and then b will be the maximum power, which will just be n. Now you know this part is a 1, so that's how that comes about. N choose 0, this part is just a 1. This part gives you n. That's where the n is coming from. Okay, and that's why here there is no coefficient indicated, because it's a 1. This is a 1. Okay, so this comes there, and then the b there. The last term will be n. That's from binomial theorem. Okay, so if you're new to binomial theorem, you should watch a video. Check binomial theorem to Assembly Institute. You understand in detail how to go about that. Alright, so this is the power n. So now in our case, where we have our b, that's where we have our h. Where we have our a, that's where we've got our x. So we can change to x raised to the power n, and then plus x h n minus 1 b. Now our b is what in this case? So our b is, I'm now missing it here. Our n remains our n, and then our a, let me just write it actually. So in our case, we've got x plus h raised to the power n, right? So we're like that. So where is our a? That's where we have our x, n minus 1. Our b is h plus dot 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 again. For the last part that we have our b is h raised to the power n. Okay, so we can try to substitute what we have now in our formula. So we'll have the limit as h approaches 0, and then we have x to the power n plus nx n minus 1 as the power, and then we've got h plus the last term is h to the power n, and then all this in brackets minus x to the power n, which is all this, don't forget, is to be divided by h. Okay, so basically what are we trying to say here? So if you try to be attentive, you're going to notice something. Okay, beginning from this term, h does exist all the way up to the last term. H does increase, okay, from 1 up the maximum value that you're going to have. Okay, now something that is quite interesting here is if you are to divide by this h that you're seeing there, if you're going to divide by that h that you're seeing there, you're actually going to notice something very interesting, that from this term, the h is going to disappear. These other terms, it won't be able to disappear because in the next expansion actually h would be the power 2, so if you divide by the h, it will still be there. Okay, then for the other part, the last term as well, if you actually get to pull it out again, you're just going to cancel 1, but the h will still remain, of course knowing that, assuming n is greater than 1, right? Okay, so what are we trying to say now? So at this point we can now say the limit as h approaches 0. Well, so if you try to remove the brackets here, you will notice that actually this term and that term can actually subtract, right? So what will stand out will be nx n minus 1 multiplied by h plus dot dot plus h to the power n. This ought to be divided by h. Now I've already explained what's going to happen here. It's like every single term can be divided by h, right? For the very first one, so let's try to factorize. We see what's going to remain. So if we try to factorize the limit as h approaches 0, and then on top let's put out our h. So if we do put out our h for the first part, that h will go. You're just going to remain with nx raised to the power n minus 1. For the second part, we can leave it. We know that even if we put out the h, it's still going to be an h that's going to remain, because like I said, in our expansion of a binomial, in the next term would have h squared, so the h will still be on top, so we don't care until the last term. For the last term, if we pull out h, so let's say if we add 9, 10 of those would remain with a 9, so that would just like reduce by a 1, but the h would still be on top, right? And then this is all divided by our h on the bottom. The reason why we are avoiding to substitute there and then is we don't want to divide by 0. So now we have the limit as h approaches 0, the h can divide, so we don't have it anymore on the denominator. So at this point now at liberty of this actually substituting. So you notice that from this term going this way, there is the presence of an h. I've explained, okay, how that comes about. So that would imply this whole part is going to be eliminated when you substitute 0, right? So that becomes 0. And so we just remain with nx, n raised to the power x, n minus 1 as a power. Okay, so that is our dy dx from first principles. And actually, if you try using the power rule, you actually prove that n times 1 is n, and then reduce the power by 1. As simple as that is. So basically, that's how you go about this question.